The history of wind power is certainly long, and historians believe as early as 5000 BC, when sailors on the Nile River depended on the power of wind for propulsion. At about 1000 AD, the Persians were the first to harness wind energy to pump water and also use the wind resource to boost their food production. They used the wind to grind their grains. In Europe, the harnessing of wind energy was realized in about 1300 AD. The Dutch people are famously known to have used wind energy to help them out in reclaiming flooded land to use for agriculture and human settlement. The United States became the first country in the early 1980s to generate electricity from a wind turbine. The turbine was rated 1 megawatt. During about the same period, California became the first state in the United States to develop a wind farm, leveraging the federal government incentives. The wind farm generated 1,000 megawatts, enough electricity to power about 200,000 homes in California. Wind turbine efficiency has tremendously improved from the 1980s to the present day. This efficiency can be directly attributed to the increase in the size of the turbines, improvement in research and development of turbine parts and systems, and improvements in manufacturing. Turbine parts can now be manufactured at record time to meet demand and supply requirements in the wind power industry. Advancement in material science has enabled the creation of stronger materials like fiberglass and resin, which are used in the manufacturing of the turbine's blades and the nacelle. Turbines are exposed to the vagaries of weather and therefore have to be very durable to withstand this degradation for about 25 to 30 years of operations. There are two major types of turbines: vertical wind turbines and horizontal wind turbines. Vertical wind turbines can also be referred to as vertical axis turbines and have blades that are attached to the top and the bottom of a vertical rotor. A common example of a vertical axis wind turbine is the Darrieux wind turbine, patented by the French engineer Georges Darrieux in 1931. Horizontal axis wind turbine is the majority in the world. They have 3 blades installed which rotate in the presence of wind like an aircraft propeller. Turbines can be classified as small-scale turbines or large-scale turbines. A typical large-scale wind turbine has a rotor diameter ranging from 50 meters to 100 meters. It produces power between 1 and 3 MW. When compared to large-scale wind turbines, small-scale wind turbines are those which have their rotor diameter ranging from 3 to 10 meters and have a power capacity of 1.420 kilowatts. A turbine has the following parts. Blades enable the rotation of the turbine generator when exposed to wind flow. They are 3 in number. Hub: this component holds the 3 blades in position and allows the twisting of the blade's pitch to maximize the speed of the turbine with regards to the optimum production of electricity. Nacelle: this is the space where the generator is housed and other electrical components. Tower: the tower holds the 3 blades at the right position where the wind pressures are adequate to generate electricity. At such positions, turbulence that might impact the optimum generation of electricity is averted. Towers are usually made up of steel. For a turbine to operate, it must be facing the direction of wind flow. How does a turbine orient itself to the wind direction? The turbine rotates the nacelle and the hub in the direction of the wind. The action to rotate in the right direction is due to the wind vane mounted at the top of the nacelle. The wind vane determines the direction and speed of the wind. This information is fed to the computer system on board the nacelle. The computer instructs the nacelle to yaw towards the direction determined by the wind vane. While in the right direction, the blades are able to twist according to the wind speed to generate 2 types of forces: a lift force acting perpendicular to the direction of the wind speed, and drag, acting towards the wind direction. A combination of these forces causes the blade to spin. The hub is connected to the gearbox through the drive shaft. The gearbox multiplies the rotation of the blades by about 100 times, which translates to 1500 revolutions per minute. The kinetic energy from the wind is now converted to electric energy by the generator in the nacelle. The electricity produced then travels from the nacelle to the base of the tower to the adjacent step-up transformer. This transformer steps up the electricity to a higher voltage, which is then transmitted to the substation. The substation further steps up the voltage to the specified value required for transmission to the national grid, which is responsible for distribution to the final user. Turbine efficiency has been improving over the years since the first wind turbine began operations in 1979 in the USA. In terms of the unit price reductions due to this efficiency, the price of wind power has tremendously reduced from 40 cents kilowatt hour to less than 5 cents kilowatt hour in 2022. This efficiency can be attributed to the following technological advancement in the wind power generation by turbines: optimization of the blade aerodynamic properties with the blade adopting a curved shape as opposed to the earlier flat shape. The curved shape operates on the sample principle as an aeroplane wing, which facilitates high-speed airflow above the wing and low-speed airflow below the wings. The difference in pressures causes the turbine to rotate. Normally the blade's revolutions per minute (RPM) are between 12 to 20 depending on the wind speed and power rating of the turbine. With the increase in computing power, computers have been integrated as part of the turbine control and operations systems. As part of the turbine's intelligence system, the turbine can be able to autonomously track the wind direction and be able to orient itself to that direction of the prevailing wind. To maximize the rotation of the blades, also known as pitching, the blades can twist along their horizontal axis from 0 to 90 degrees through the complex computer systems installed on the turbine. The control team can also manipulate the operations of the turbine from the substation and from anywhere on the globe through a complex SCADA system. Improvements realized in manufacturing and materials science have enabled the production of durable materials like steel, aluminum, fiberglass, resin, and metal alloys, which forms the supply chain of turbines. This has facilitated mushrooming of wind farms all over the world, with China taking the lead in the number of the total installed turbines, followed by America. In terms of the turbine efficiency, there is an upper limit calculated by German physicist Albert Betz. Betz established that, no matter how fast the wind is blowing, the maximum kinetic energy that can be converted to electrical energy is 59.3% of the wind's energy. Wind power has the lowest power cost rating of less than about 5 cents per kilowatt hour. A single commercial-sized turbine rated 1.5 to 2 megawatts can power up to 500 homes. Climate change activists have suggested the transition from fossil fuels to renewable energy sources to avert a global warming catastrophe.
And there is perhaps no industry with more potential to create jobs now and growth in the coming years than clean energy. For decades, we've talked about the importance of ending our dependence on foreign oil.
Before you leave, our team will be very happy if you can give this video a thumbs up. Remember to subscribe and click the notification bell so that you can be notified every time we upload a new video. Thank you for watching, and see you in our next video.